Bismillahirrahmanirrahim. Today's lecture is about theorem 15.1.1, but before going into its proof we need to recall a few concepts. The first is the similar triangles. Definition of similar triangles. What do you mean by similar shapes or triangles? Any two triangles having the same shape, they may have different sizes, but if their shapes are same, then those triangles are called similar triangles. Okay, two or more triangles having the same shape, their shape should be same, they may differ in their sizes. For example, if I take this triangle, okay, and let me draw one more triangle which has the same shape. Now shape of the triangle is determined by its angles. So if the angles of two triangles are same, then the shape is always same. For example, if this is 60 degrees, let me say, okay, and let this angle be equal to, let it be 60 degrees too, or let us take some other angle. Suppose this is 50 degrees. Okay, 60 plus 50 makes 110. Now we will take this angle. If we take this angle equal to 70 degrees, okay, then, and similarly if you have in this triangle the angles are also same as this triangle, then they will always have the same shape. Okay, so if we want to prove whether the two triangles are similar or not, we just need to prove that they have their corresponding angles are same. If the corresponding angles are same, then they will be similar to each other. Okay, they will have the same shape. For example, two right triangles, if I draw two right triangles, they may not have the same size, but if they have all right triangles have the same shape, so all right triangles are similar to one another. Okay, so this is what we mean by similar triangles. Triangles having the shape, they may have the same size or they may not have the same size, okay, but their shape are the same. If the shape of two triangles are same, we said that those triangles are similar. Okay, these two triangles are not similar because their shape is not the same, but these two triangles are similar. These two triangles are similar, although they do not have the same size, but their shape is same. Now in order to prove that two triangles are similar, we need to prove that their corresponding angles are same. So note down this result, that two triangles are similar if their corresponding angles are the same. Okay, so if the corresponding, for example, in this triangle A B C, we will take the corresponding in such a way that for corresponding to A we will take D, because these two angles are congruent. Okay, so take the correspondence, always take the corresponding in such a way that the equal angles are corresponding to one another. Here angle A is congruent to angle D, so I have taken corresponding to A, I have taken the vertex D. Okay, and corresponding to B, I have taken the vertex E, because B and E are given to be congruent, and corresponding to C, I have taken F, because these two angles are congruent. Okay, now angle A is congruent to angle D, angle B is congruent to angle E. Okay, it's enough to prove that the two angles are congruent, because if these two are congruent, then obviously the third one will also be congruent. So it's enough to state the two angles, the congruency of two angles. If two angles of a triangle of one triangle are congruent to the two angles of the other triangle, then the third triangle is also congruent, because we know that the sum of the three angles is always equal to 180 degrees. So here the third angle can be obtained by subtracting, for example, here D and E. If we subtract 60 and plus 70 from 180 we will get 50. Here also A and B are same, so subtracting angle A and angle B is the same as subtracting angle D and angle E from 180. Then obviously the third angle will also be the same, so it's enough to prove that two angles of if you have two triangles, then if you prove two angles to be congruent to one another, that will be enough to prove that those triangles are similar to one another, and this is called AA postulate. Okay, this is for similar triangles. A postulate. If two angles are similar, the third one will obviously be similar because the total of the three angles sum up to give you 180 degrees. So it's enough to prove the two angles of this triangle to be congruent to two angles of triangle DEF to prove that these two triangles are similar, and this is called AA postulate, that if two angles of one triangle are congruent to the corresponding two angles of the other triangle, then the triangles are similar. Okay, triangles are similar. We are going to use this postulate, and also we are going to use one another theorem, and that theorem is theorem 14.1.4 in your book. We are going to use that theorem to prove theorem 15.1, and the theorem states that it is also about similar triangles. That is the property of similar triangles, that if two triangles are similar, theorem 14.14, it states that if two triangles are similar, then their corresponding sides are proportional. Now we know that the word proportional comes when we have equality of two ratios. Now the statement of this theorem is says that if you have two triangles, suppose you have triangle ABC that is similar to triangle DEF. Okay, DEF. Now if you can prove that this triangle ABC is similar to triangle DEF, if you know that these two triangles are similar, then their corresponding sides are always proportional. It means that the ratio between the corresponding sides always remains the same. Okay, corresponding sides are proportional means that the ratio between the corresponding sides, for example, the ratio between AB, okay, measurement of AB over measurement of DE. If you take the ratio between the corresponding sides, okay, corresponding to AB we have DE, that will always be equal to, corresponding to BC we have EF, BC over EF, okay, and corresponding to AC, measurement of AC over will be equal to measurement of the ratio between these two corresponding sides. This ratio will always be equal. Okay, so whether you take AB and DE and find its ratio, or you take AC and DF, okay, AC and DF, you take the corresponding sides and take their ratio, this ratio always become equal, and equality of this ratio is called proportionality. Okay, whenever we use the word proportional or proportionality, it means we are talking about the equality of ratios. So if two triangles are similar, then their sides are always proportional. This is theorem 14.1.4. This statement we are going to use in this theorem 15.1. Okay, so these are the basic definitions and theorems we are going to make use of. We are going to get help from these theorems, and we are going to prove our current theorem. So let's start theorem 15.1.1, which is the famous Pythagoras theorem. This is also called Pythagoras theorem, as you already have studied the statement. Now today we are going to find how to prove this theorem, Pythagoras theorem. Now we are about to start theorem 15.1.1, Pythagoras. Let me write the statement of the theorem. Now the statement of the theorem is that in a right triangle, the square of the length of hypotenuse is equal to the sum of square of the other two sides. So what does it state? That if you have a right triangle, let ABC be a right triangle having the angle of 90 degrees at the point C. Now we know that the side which is opposite to the 90 degrees is always the hypotenuse, and we also know from the properties of right triangles that this is the longer of the three sides. Okay, this is the longest one. This side is always longer than this and this side. Now we have to prove that the square of this hypotenuse, the square of this length, is equal to the sum of squares of these two. It means that if we square these two lengths and then add them, then the answer will become the same as if we square this side. So what they have given to us is that they have given us a triangle ABC. We are given, and also I have named this length as small b. The length which is opposite to the vertex B, I have named it as small b. We generally name it like this. And the side opposite to vertex A, I have taken this length to be equal to A, and the length opposite to vertex C, I have taken that equal to C. So we are given triangle ACB. At the point C we have 90 degrees. Okay, at the vertex C we have 90 degrees. So we are given triangle ACB is a right triangle, okay, in which measurement of angle C is equal to 90 degrees. Okay, and measurement of AC is equal to B, measurement of AB is equal to C, and measurement of BC is equal to A. We have to prove that the square of this side, that is C square, is equal to A square plus B square. Okay, square of this side is equal to the sum of square of these two sides. Now in the construction, what we are going to do is we are going to drop a perpendicular from C to AB. Okay, here we are going to drop a perpendicular. Perpendicular means we are draw a line in such a way that it passes through C and it makes an angle of 90 degrees. Okay, it makes an angle of 90 degrees with this side. So we say that we have dropped perpendicular from C on AB. Okay, we are going to draw this line such that it passes through C and it is perpendicular to AB. Now if you look at this, we have two triangles at the moment. This is triangle, let me name it triangle 1, and this is triangle 2. So by drawing this line we have obtained two triangle. Let me name this as, this point as D. So in the construction, what we have done, drop a perpendicular, drop perpendicular from C on A, B, okay, such that it meets AB at point D. Okay, so we have dropped a perpendicular CD from C on AB, and it has formed two triangles. And let me name these, let CD, the length CD be given the name H. Okay, this length, let CD be, measurement of CD be equal to H, and as this line AB is divided into two parts, BD and AD, so I am going to name them as X and Y. Okay, so take the length BD to be equal to Y and AD to be equal to X. Okay, so this is our construction, and here drawing CD, this CD perpendicular has divided this triangle into two triangles. Okay, we have 2 triangles as a result. We have 2 triangles we have two right triangles. Okay, this triangle is also right triangle because this angle is 90, then this is also 90. Okay, so we have the angle 90 over here also. Okay, these are the angles which are equal to 90. This whole angle is 90, and over here this half plus half, both these angles are 90 degrees. So it means that we have three right triangles. Okay, triangle ACB, the bigger one. Okay, and two right triangles. One is CDA, this triangle, and the other is BCD. We have three right triangles. Let me name them. We have obtained triangle BDC, 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 and triangle ADC, both right triangles. Okay, so this is now what we have done up to now. Now I'm going to start the theorem. I will write to prove somewhere over here, so you know that what we want to prove. And remember that the given is that we have a right triangle having right angle at the point C, and we have divided it into two right triangles. One is ADC and the other is BDC. So we had triangle ABC. Okay, and the construction, we constructed this perpendicular CD, which is perpendicular to this side. Now as a result we have two triangles. Okay, I have drawn this triangle over here. I have first ADC. I have drawn this right angle. We have three right angles, ACB, bigger one, then the triangle ADC, which I have drawn here, ADC, and take the lengths same as in this figure. Okay, AC is equal to B, so I have taken AC equals to B. This is the same triangle as this one. I have just erected it, and then I have placed it here. Just suppose we have picked this triangle from this position and we have placed it here. We have placed it and then we have flipped it. Then we are going to take, we will be having this triangle. Okay, so triangle ADC, AD is X, this length is X, AC is B. I have taken the same names as in this triangle. CD is H. Similarly, take this triangle and draw it over here. Taking CD is H, so I have taken CD here, also H. It has the side BD equals to Y, BD is Y, and BC is A, so I have taken BC over here also A. So I have taken this triangle from this figure and I have drawn it in separately in this space. Okay, this because we are going to using the theorem 14.1.4, and from there we are going to take the sides of this triangle. Now what we have to do is I am going to compare this triangle ACB with triangle ADC first, and then I am going to compare ACB with triangle CDB. Okay, and I will prove them similar, and then in each case we are going to use theorem 14.1.4. After proving them similar, theorem 14.1.4 is about similarity of triangle, which tells us that if two triangles are similar, their sides are proportional. So I am going to prove them similar first, and then I am going to use theorem 14.1.4. After that we will get two equations with the help of which we will get this result what we need to prove. Okay, so taking triangle ABC corresponds to triangle ACB. Okay, so I have taken triangle ADC. ADC is this triangle. Okay, ADC. I am comparing it with ACB, this bigger one. Okay, now in both these triangles we have an angle common to this triangle. Okay, this angle A lies in this triangle ACB as well as in triangle ADC. Okay, I am taking these two triangles, triangle ADC, I am comparing this triangle with triangle ACB. In both the triangles angle A is similar. Okay, angle A is congruent to angle A. This is because this is the common angle of both both the triangles. Now angle A of this triangle ACB is the same as angle A of this triangle ADC, because this is the common angles of both the triangles. So angle A is congruent to angle A. Okay. And angle D of this triangle is congruent to angle C of this triangle ACB. Okay, because in ACB, C is the right triangle. Angle D is congruent to angle C. Okay, angle C, because both are right triangles. Right angles. Okay. After construction, this is the result what we obtained. So in construction, we had dropped a perpendicular from C to D, which has made this angle equal to angle D. So angle D is congruent to angle C of this triangle. Angle ADC is congruent to angle ACB. Okay. So angle D is congruent to angle C, or we can write angle ADC. Okay, ADC is congruent to ACB. Is congruent to angle ACB, because both are right triangles. Now we know that in a triangle, if both the angles are same, if the two angles of this triangle are equal to the two angles of the triangle ACB, then the third angle will also be equal. Now what's the third angle? We have taken angle A and angle D. The third angle over here is angle ACD. Okay, angle ACD will also be congruent to which angle? We have taken angle A over here, angle D. So angle ACD will be congruent to the third angle. What is the third angle of this triangle? We have taken angle A of this triangle. We have taken angle ACD of this triangle. Now the third angle is angle ABC. ABC. The third angle will also be equal, because in the right triangle, we know that one angle is 90 degrees and the other two are acute angles whose sum is equal to 90 degrees. So these two angles are always complementary. Okay, and they are called complement of one another, because if this is 30, then this will be 90 minus 30, that is 60. Okay, so these two angles are always complement of one another. So if two angles are congruent, the third one, which is the complement of this one, will also be congruent. So this is the complement of the complements are also congruent. If the two angles are congruent, because one angle is 90 of both the triangles, then this is complement of angle A and this is also complement of angle A. So it will, both of these will be equal complements of angle A. Okay, they are complements of the same equal angles. Therefore, they are also going to be equal. So according to AA postulate, triangle ADC will be similar to triangle ACB. This is the symbol which we use for similarity. Okay, it means the shape will be same and the size may not be the same. It may or may not be the same. Okay, but their shapes will be the same. Therefore, they are similar to one another. And we knew that these are right triangles and they obviously have the same shape. So these two triangles are similar to one another. Now, as you have proved that these two triangles are similar, therefore by theorem 14 point, let me write this as, this is because of AA postulate. Okay, now as the two triangles are same, therefore their sides are going to be proportional to one another. The corresponding sides are going to be proportional. Okay, so measurement of AD over measurement of AC now AD is corresponding to AC, so their ratio will be equal, and corresponding to DC we have CB. Okay, DC over CB, measurement of DC over CB will be equal to measurement of AC. Okay, AC over AB. This is because of theorem 14.1.4. It states that similar triangles have proportional sides. If two triangles are similar, they will always have proportional sides. It means the ratio between their corresponding sides will be always equal, and this is called proportionality. Okay, so now let me put the values. AD, we had taken AD to be equal to x. It means x over AC was B, DC is H over CB. What is CB? This is over A is equal to AC. What is AC? AC is equal to B. Okay, I am just replacing their lengths. AC, the length of AC was taken to be B, and AB was equal to C. Okay, this whole AB was taken as C. It is the sum of x plus y. Now I will drop this one because it will be enough to take these two equal. Okay, x over B is equal to B over C. From here, shifting B to this side, what we have? X is equal to B square over C. Okay, so this is x. Okay, x is equal to B square over C. Similarly, we will take triangle ACB and the second triangle now, and we are going to prove them similar as we did in this portion, and then I'm going to take the proportionality of the sides, and we are going to arrive at another result, and then using this result and the result that we are about to prove, we will be able to bring this equation. Okay, so I'm going to erase this, and now the next step, make this as equation 1. Okay, and I'm going to take triangle BDC. Okay, BDC corresponds to triangle BCA. Okay, in this triangle now again we have angle BDC. I am taking this triangle and triangle ABC, this one. In this, B is the common angle of both the triangles. Okay, this angle belongs to both this smaller triangle and this bigger triangle also. So B is the common angle. Okay, angle B is congruent to angle B. The reason will be same as before, common angle of both the triangles. And in this triangle, angle C, in BDC, this one, in BDC, the right angle lies at the point D. So angle BDC will be congruent to angle ACB of this triangle. Angle ACB, because both are equal to 90 degrees. Okay, the reasons are the same as before. I am following the same steps for these two triangles. Okay, so the third angle, which is angle A in this triangle, angle B is congruent to angle B. Okay, angle C of this triangle is congruent to angle D. So the third one, the complement will be here. Angle C, BCD will be congruent to this one, BCD. This angle will be congruent to angle A of this triangle. Okay, so angle BCD will be congruent to angle A of this triangle, angle BAC, because angle A is the complement of angle B. Okay, and in this triangle, angle C is the complement of angle B. As angle B are same in both the triangles, therefore angle A of this will be equal to angle BCD. Okay, angle BAC will be equal to angle BCD of this triangle, because C is the complement of B. Here also A is the complement of B. As B are same, so 90 minus B will be A. Here 90 minus B will be this angle. So these two angles BCD will be congruent to BAC. That is what I have written. It means that both the triangles will be BDC will be similar to triangle BCA. They are similar triangles, so their sides will be proportional. Now taking the proportionality of the sides, BD over measurement of BC will be congruent to measurement of DC. Okay, corresponding to DC we have CA, measurement of CA, and that in turn will be congruent to measurement of BC. Okay, corresponding to BC we have BA, measurement of BA. Now again doing the same, repeating the same. This is because of A postulate, this is because of theorem 14.1.4, and now I'm going to replace BD. What is BD? BD is equal to Y. So Y over BC. What is BC? BC is equal to A equals to DC is H over AC is B. Okay, and BC, what is BC? BC is again A over AB is the length C. So again I'm going to drop this equality. I need only this one. Okay, this is equation 1 that we had already proved. Let me write it here. X is equal to B square over C. This we have already proved. Okay, and I'm going to erase it from here. Now from this result we have y is equal to a square over c. Okay, now this is equation 2. Now adding 1 and 2, what we get? X plus y is equal to b square over c plus a square over c. Now we know that x plus y is equal to c from here. Okay, AB was c and x plus y is equal to c is equal to b square plus a square over, as the denominators are same, I am going to write this as this. Okay, this is adding 1 and 2. Now shifting c to the left hand side will be c square is equal to a square plus b square, and this has proved the result. Okay, so this is how we have proved this result. So we have used